6.6 higher paper, the test. Just going to go through this quickly. So you're going to get given a method here, or sometimes you have to come up with a method. When modeling radioactive decay, we can use dice. And you can see that they've got one group's results and then the class results, okay? So sometimes you're asked to spot a pattern, but not in this case. It's just giving you the results. Just recognize that we're starting with 400 there and we're starting with 50 there. Okay, so first question is, each group's results was added together. Give one reason why we do this. So anytime there's an average or a mean question, it's to reduce the effect of anomalies or reduce the number of anomalies for 1 mark. The next question then is a graphene question for, how many marks is it? I think 3 up there. And you literally just take the data and you plot it for the class results, because we're starting 400 there, and then you plot in the remaining data using what you've got. If you do it correctly and draw that curve, you're going to get your 3 marks. It's asking you then to use the table to estimate the half-life. Well, if we're starting with 400, half of 400 is 200. So get the nearest one to 200, which is the 190. And let's have a look what half-life that is. Well, it's 4. So that's where I'm getting that answer from. And it says now use the graph. So I'm just going to get half of 400 again, which brings me down to, oops, press the wrong button then, 200. I'll draw a line across, I'll bring it down, and it's around about 3.8. I know the graph paper is not the best on here, but it'll be okay on the day. So 3.8 for 2 marks there. 1 mark for drawing the line, 1 mark for giving the answer. Same question, suggest why it is better to use the graph rather than table. It's because it's going to give you a more accurate value, okay? It's more precise for 1 mark. Now use the graph to find how many rolls it took, the number of dice, to get to a quarter of the original value. Comment on your answer. So I've said 7.6 because it's 2 half-lives. So if 1 half-life is 3.8, then we need 2 half-lives is 3.8 plus 3.8. And I can use, not that I've drawn it there because I didn't want to confuse you from the original question, but we can use our graph then. A quarter, 100 is going to be, you'll be able to see that it's around about that 7.8 mark there, okay? Then we come on to half-life, and there's 4 marks available here, all right? Now, I could have used 1 table, I could have extended this table, but I thought I'd do it in 2 just to show you what my method. This is where the table comes in really handy, because now we can work back. So from the question, it says that after 210 seconds, it drops from 80 counts to 10 counts. So if I start with 80, my activity, and then half that every time to get to 10, I know then if I do my table, so 0, 1, 2, 3, 4, always start with 0 on time as well. You're not given a half-life this time, but you're saying after 210 seconds, it drops to 10. So if 3 half-lives are worth 210 seconds, what's 1 half-life worth? Well, it's just dividing by 3 then. And that's where this table comes in really handy. Okay, so 70. So if you think about it, if each half-life is 70, 1 half-life is 70, 2 half-lives 140, 3 half-lives 210. And that's the way it would work. And you can see I made a bit of a mistake there, and I forgot to fill out that top line. But that's 0. In fact, let me do it now, so that we're all okay. So 0, 1, 2, 3, 4, 5. Because the top line is just number of half-lives, isn't it? Oops. So this time it's asking me now to calculate how long, so it wants the time now, it would take to drop from 80 to 2.5. Well, I already know my half-life because I just worked it out from this one. So now 0, 70, 140. So I didn't know how many I need, but I know I need to get down to 2.5. I start at 80, half it every time, get down to 2.5. So it takes 350 seconds. All right. What's it measuring? It's measuring becquerels, B and Q. You can do it if you B and Q it, and you'll get a mark for just B and Q. Question 2 then. It says radioactive carbon-14. It's got a half-life of 5,700 years. Explain carefully what the following statements mean. So what does carbon-14... So what does it mean if carbon-14 is a beta emitter? For 2 marks, you need to refer to the nucleus, and you need to refer what type of decay beta is. So it's an electron. So the nucleus emits an electron. Fast-moving electron I've put there, but the mark scheme will just take electron. My opinion, the more information you get down, the more you are likely to get the mark. What does it mean if carbon-14 has a half-life of 5,700 years? Well, it means that in 5,700 years, the activity, or the mass, or the number of carbon-14 atoms will halve. Okay? It's going to decay by half. So it's kind of a question asking you define half-life. So if you can define half-life, you should be able to answer this question. Then you're given some sort of graph. I say some sort of graph. You're given a graph there with count rate on the side. So that's your activity. And then your time on the bottom. And you've got a nice little curve. And then the question is, suggest a reason why the wood from the hut gave a lower. So this information is in the question. So I think this bit, without reading it all, is telling you that a tree that is still alive still takes in carbon. Okay, so its decay curve is going to be, so its rate of decay is going to be obviously shorter. And this, so it says that a sample of living wood near an ancient river gave around 32 counts per minute. Suggests a reason why the wood from the hut gave a lower count. Well, I've said dead wood decays, therefore decreasing the activity. So the activity from the dead wood is going to decay, whereas the living wood won't. So it doesn't take in the C14, okay? Whereas the living stuff does. For 2 marks, I honestly think this is a bit of a, it's badly worded for the question. I had to look at the mark scheme for this to see where they were going. I managed to pick out where they were going. If you study this question, you'll see that why my answer makes sense. And then we use the graph to estimate the age of the village. Well, it says, again from the question, that it's giving 14 counts per minute. So I would go to my graph then, and I would go to 14 counts per minute and bring my line across, and it's around about 6,800. And you get, you can get a range there. If you say 7,000, you probably get the mark for that. Okay? Explain why the safe disposal of radioactive waste is essential but costly. That's really the question. They've given you all this information here, but that's the question for 3 marks. Well, radioactive decay is essential to dispose of because it's dangerous to humans, and the length of time that it's active. Okay, they've got really long half-lives, says there. Why is it costly? It's because it's expensive to contain it. Okay, you can't just throw it down a toilet. You've got to contain it in barrels of that's surrounded by concrete and lead, and then you've got to transport that waste to somewhere safe. So that's why it's expensive. Then we come to a question again on half-life. Only 2 marks this time, and you don't really need the table. Well, I would say the table helps because you can see what I'm doing then. But if you're quite good at numeracy, then you'll recognize, because we're only dealing with 2 hours and 1 hour half-lives, it should be okay. But I always do a table just to see what's happening, and I do the table. 0 to 3 there, 0. I don't know what so for X, my half-life is 2 hours. And again, you really need to read this question to pick out where I'm getting my information from. X starts at 160. Okay, so that's all we need to know there. And then Y starts at 160, and it's got a half-life of 1 hour. Calculate the count rate after 2 hours for both of them. So this is a mixture now, it says there. Okay, it's a mixture. So after 2 hours, my X goes to 80 counts per second. And after 2 hours there, my Y goes to 40. So 80 plus 40 is going to give me 120 counts per second. For 2 marks, a lot to do there. But again, you know, if you weren't doing the tables and you can kind of recognize what's going on here, I guess it is only worth 2 marks. It seems like I've done a lot there. But again, you need to study the question, where I'm picking the information from. Okay? And if you need to rewind, rewind. A separate question then, carbon-14 is present in all living material. It's got a half-life of 5,700. Name the part of the atom which emits the beta particle, which is going to be the nucleus for 1 mark. What will the activity be after 5,700 years? Well, it says that that is 1 half-life there, right? But again, I've done a table because I might need it down by here anyway. So I've done my table. The 1 half-life is 5700. It's dropping from 200 to 100 there. Okay, so 100 after 1 half-life. And that's what it's asking. After how many years will the activity have fallen to 50? So again, I can use this table now after 11,400 years. And that's another mark. And I think that is the paper, isn't it? Yep. So, hope you enjoyed this video, and I hope you've got something out of it.